Hello everyone. In this video, we are going to discuss about energy sources, gaseous fuels and biodiesel synthesis process. So coming to gaseous fuels, as we already discussed the advantages of gaseous fuels over liquid fuels and solid fuels, these gaseous fuels are having high calorific value and low ignition temperature and burns cleanly without causing any pollution. And according to that or based on the origin, those are classified into two types: primary gaseous fuels and secondary gaseous fuels. So primary gaseous fuels are nothing but the fuels which are originated from the natural sources. Best example, natural gases. Then from these natural gases, different gases will be synthesized or fractioned, then those are called as secondary fuels. For example, coal gas, water gas or oil gas. So now coming to this picture which explains oil well structure, in which the gases which are accompanied along with the oil in the oil wells are called as natural gases. So these natural gases are extracted and further treated to form secondary fuels or secondary gases. Then coming to the first type of natural gas, composition of natural gas. So it contains maximum percentage of methane and of course 88.5%, and next ethane 5.5%, the next propane 3.7% and butane 1.8%, and it also contains little traces of pentane, hydrogen, carbon monoxide, carbon dioxide and somewhat higher hydrocarbons in little traces in a range of 0.5%. And the calorific value of natural gases will be in a range of 8,000 to 14,000 kilocalories per cubic meter volume. So calorific value of natural gas is very higher because it contains maximum methane, that is maximum carbon content and less pollution causing elements. Then coming to the applications of natural gases. So as we all know, natural gas is an excellent domestic fuel as well as industrial fuel. Then to prepare some chemicals like methanol or carbon black or formaldehyde, this natural gas is also used in the synthesis process. Then natural gas also used as a source of hydrogen gas. From this hydrogen gas, ammonia can also be prepared by reacting with nitrogen. So this hydrogen is also extracted from natural gases. So this is about composition and applications of natural gases. Then coming to next secondary gaseous fuel, that is LPG, liquefied petroleum gas. The major composition of liquefied petroleum gas, that is LPG, is N-butane, isobutane and butylene, propane and negligible amount of propene and ethane also. Then LPG is supplied under pressure in a containers after treating with mercaptans. So these mercaptans are sulfur containing components which will help us to detect the leakage of gas. So generally LPG is odorless. So to detect the leakage, it's not possible to detect the leakage of LPG without mercaptans. So mercaptans are helpful for the detection of leakage of gases from the cylinders. LPG is highly inflammable and highly volatile, colorless liquid under pressure. And coming to the calorific value of LPG, it is far higher than the liquid fuels. Of course, it is closer to 55,000 kilocalorie per kg of calorific value. And it is also knock resistance and it burns cleanly. So these are the composition of LPG and the characteristics of LPG. Then coming to the applications of LPG, this LPG is used as or for heating purpose, and of course it is also used to produce heat as well as to produce some electricity. And so it is also used in vehicles or automobiles as a fuel. So LPG is also called as auto gas. And next, LPG is treated or LPG is used in trains along with tetramethyl lead as a fuel. So we can also use this LPG as a fuel in railway engines and by mixing it with tetramethyl lead, TML. Then in comparison with the petrol, LPG burns cleanly, and it is most economical and pollution free, and it won't produce any harmful gases for the pollution which causes pollution, and is also used in refrigeration purpose and as a refrigerant. So these are the applications of LPG. Then we will discuss CNG, compressed natural gases. CNG is composed of 90% of methane, maximum percent of methane, and other constituents like ethane and propane, and some little traces of gases like carbon monoxide and nitrogen. So CNG is made by compressing natural gases to less than 1% of its original volume at STP, standard temperature and pressure. And when the natural gas is compressed to, or natural gas is compressed at 100 atmospheric pressure, or when the natural gas is cooled to minus 165 degrees centigrade, then the natural gas is converted into CNG, compressed natural gas. So it is stored in a containers with a pressure of 200 to 248 kg per square centimeter of pressure. So it is odorless, just like LPG, and non-toxic, then environmental friendly fuel. It does not cause any pollution. Then coming to the applications of, before applications, we will discuss the calorific value. So it is also closely matches with that LPG. So a calorific value of CNG is 50,000 kilocalorie per kg almost, and this high calorific value is because it does not contain any polluting agent. It does not having any non-combustible elements. It is having the combustible elements. The maximum percentage is carbon itself. So the calorific value is very, very higher, and the CNG energy density of CNG is 53.6 megajoules per kg or 9 megajoules per liter. So this is energy density of compressed natural gases. Then we'll move to applications of CNG. So CNG, as we all know, it is used in transportation sector. So nowadays most of research is going on in producing some eco-friendly fuels. So this is also a best example for eco-friendly fuels used in automobiles like cars or autos or some bikes also. Then so it is also used for cooking and then heating purpose, and CNG is also used in drying of clothes. In dry cleaning process will be using CNG. So here CNG will produce 50% more cost effective when it is compared with electricity when we use this in dry cleaning purpose. Then manufacturing of some chemicals like acetic acid, ammonia, methanol, butane, propane, ethane, etc. So CNG is also used in the synthesis process of chemicals, and so it is also used in the manufacturing of plastic and some other important organic chemicals also. Then so CNG is used in the production of glass, fabrics, steel, paints, etc. And it is also used in the preparation of protein rich animal or fish feed. CNG is also useful in the preparation of protein rich animal feed or protein rich fish feed. So these are the applications of CNG. So now coming to biodiesel. So biodiesel is a renewable source, renewable fuel, and if you look into the diesel and whose carbon chain length may range from C15 to C16, so generally used as a conventional fuel in the automobiles, but we have so many disadvantages in case of diesel, as it produces much smoke, much carbon dioxide and then carbon monoxide, and cost is also very high. And to obtain this diesel, and we have been depending on foreign countries for this to meet the requirements of fuels nowadays. But when we synthesize this biodiesel from that natural sources or from the vegetable oils or used oils or animal fats, these limitations can be overcome, just like we can decrease the pollution and the foreign dependence also decreases, and cost is also we can cut down. So these are the advantages of biodiesel, and so here we will discuss what is the process for the synthesis of biodiesel from vegetable oil or animal oil. So it can be obtained in the pure form. So then we call it as B100, which contains only biodiesel, and it can also be obtained like B2 grade, which contains 2% of biodiesel and 98% of diesel, conventional diesel. And we can also have B5 grade or B5 type, in which 5% of biodiesel is mixed with 95% of petroleum diesel. The next B20, in which 20% of biodiesel is mixed with 80% of conventional petroleum diesel. Then coming to the reactions of biodiesel preparation. So the process is called as trans-esterification. So in this trans-esterification process, we'll take one alcohol and we'll mix this alcohol with catalyst. Here we can use sodium hydroxide or potassium hydroxide as catalyst. So if we take methanol as alcohol and sodium hydroxide as catalyst, so the sodium hydroxide splits into Na plus and then OH minus, and this OH minus will abstract hydrogen from methanol. So OH minus will abstract hydrogen from methanol and it leaves methoxide ion for esterification process. So these methoxide ion reacts with triglycerides of present in oil or animal fat and results in esters of fatty acids. So these esters of fatty acids will consider as biodiesel. So here OH minus and H plus ion will form into water, and here we have to take care about while the addition of methanol and then sodium hydroxide, then it should not contain an aqueous component, it should not contain water component, because excess of water component will lead to unwanted reaction which might result in the formation of soap instead of forming biodiesel. So care must be taken not to add any water component, not to take excess of water component here. So we should take dry methanol and then dry sodium hydroxide samples before starting the experiment. And this reaction is also depending on temperature. So generally it can be operated between 40 to 65 degrees centigrade temperature, and with the increase in temperature the rate of the trans-esterification reaction also increases and the time also decreases. So here it takes 1 to 2 hours if we heat 60 degrees centigrade, and it takes 2 to 4 hours if we maintain the reaction at 40 degrees centigrade. And if the reaction temperature is far higher than 65 degrees centigrade, then we have to maintain a pressure vessel, because methanol starts boiling at 65 degrees centigrade. So there is a chance of escaping of methanol in the form of vapors. So this is about some steps involved in the trans-esterification process. Now we'll discuss the reaction. So this is methanol is a precursor material, and so we are using oil, vegetable oil or animal fat here. Oil, nothing but triglyceride. So here, so methanol is first reacted with sodium hydroxide, which abstracts H plus from methanol and leaves methoxide ion. So this methoxide ion now reacts with the triglycerides present in oil to form mixtures of fatty esters. So here triglyceride is nothing but vegetable oil or animal oil. The major composition of oil is nothing but triglyceride, and so it takes these triglyceride takes excess of methanol. So it requires 3 moles of methanol. So we need to add excess of methanol to the reaction mixture and sodium hydroxide as a catalyst. So sodium hydroxide abstracts this H plus and leaves methoxide ion. So it leaves methoxide ion, and this methoxide ion reacts with these triglycerides, leads to the formation of esters of fatty acid. So these fatty acid esters are considered as biodiesel, and so carbons present in triglycerides will react with OH forming glycerin. So we are getting 2 products here, biodiesel as one product and glycerin as a second product. So we can separate this biodiesel and glycerin by using a separating funnel based on the density. So that process we will discuss now. So here the schematic representation of trans-esterification. So first we will take used oil. To this used oil we will add catalyst and methanol, and so trans-esterification takes place from, if we leave it for 1 to 2 hours at 60 degrees centigrade. So trans-esterification takes place and it results in the formation of two products, one is biodiesel and next one is glycerin. So here this biodiesel and glycerin can be separated by using separating funnel. So glycerin being denser, so it settle at the bottom portion of separating funnel, which can be discarded. Then later the upper portion is collected. The upper portion is nothing but biodiesel. So upper portion is simply collected and it can be washed through water so that any impurities are there, it can be washed off. So finally biodiesel, after purification, it can be collected in the bottles or stored in the bottles. So this is the process of biodiesel synthesis process. The name of the reaction is trans-esterification. So here we need methanol and one catalyst, and next we need used vegetable oils or animal fats. The reaction is called as trans-esterification, so which might require 1 to 2 hours of time by maintaining a temperature of 60 degrees centigrade. We will get two products, one is biodiesel, next one is glycerin. So here we will get two products, biodiesel and glycerin, which can be separated by using a separating funnel. So the bottom portion will be occupied by the glycerin because the density of glycerin is higher when it is compared with the biodiesel, and from the top portion biodiesel is collected and the biodiesel is washed with water to remove excess of impurities, and finally it can be stored. So this is the process of trans-esterification. The next, so we'll discuss the biodiesel cycle now, because we have already in the first slide we have already discussed that this is the renewable source. How it becomes a renewable source. So now if we consider oil crops, so oil crops like sunflower or groundnut, so from which seeds will be collected, and from these seeds raw oil is extracted, raw or crude vegetable oil is extracted, and it will be refined to remove impurities, and this refined vegetable oil or animal fat is mixed with alcohol. That means is we are doing some trans-esterification on this refined vegetable oils with the help of methanol and sodium hydroxide, and here we are getting two products. After trans-esterification we are getting two products. One product is biodiesel, the next byproduct is glycerol or glycerin. So this occupies the lower portion in the separating funnel. So glycerin can be removed first, then we can collect biodiesel, and we can use this biodiesel in the existing diesel engines as it is. So the main advantage of biodiesel is it can be used in the conventional diesel engines, need not to prepare separate engines for that biodiesel utilization. So here we can use this biodiesel as it is in that existing diesel engines. And how we are going to recycle it? So here that by that combustion of this biodiesel, which will cause some emission of carbon dioxide, and this carbon dioxide is again used in the process of photosynthesis, which will help for oil crops. So in this manner biodiesel cycle can be maintained at neutral, and we consider this biodiesel as renewable source with this diagrammatic explanation. Then last we will discuss advantages and disadvantages of biodiesel. So coming to the advantages, so biodiesel can be produced from renewable sources. Then the biodiesel can be directly used in the existing diesel engines, and less greenhouse gas emission in case of biodiesel. The next, this is biodegradable and non-toxic, and this is positive economic impact, that means the cost is less, and foreign oil dependence can be reduced easily. We can produce our own biodiesel simply, and it shows some health benefits also because the pollution is zero or negligible. Then, so coming to the disadvantages, so you'll find some variations in the quality of biodiesel. Not all the biodiesel synthesized from all the biodiesel plants are having the same quality. So you'll find or we'll have some variations in quality of biodiesel, and it is not suitable for use in low temperature because it is made from oils, so it can be solidified at low temperatures, and fuel distribution in internal combustion engine is not uniform. That is also one of the disadvantage. Then so it slightly increases nitrogen oxide emission, which might cause some pollutions. So these are disadvantages of biodiesel. So we have advantages, so many advantages. Apart from these so many advantages, we have some fewer disadvantages also regarding biodiesel. So in this video we have covered some examples of gaseous fuels and biodiesel synthesis from vegetable oil or animal fat by using trans-acidification reaction.